If q 0 comma 1 is equidistant from p 5 comma minus 3 and r x comma 6, then find the value of x. So students, what is given here? Q 0 comma 1 is equidistant from p and r. The coordinates of p 5 comma minus 3 and r x comma 6. Now students, what is given? These two distances are equal. PQ is equals to QR. We have written here. Now we will find distance between P and Q. So we are using formula under root x2 minus x1 whole square plus y2 minus y1 whole square is equals to distance QR. This will be square root of x3 minus x2 whole square plus y3 minus y2 whole square. Squaring on both the sides, we will remove square root from both the sides. Squaring on both the sides, x2 minus x1 whole square plus y2 minus y1 whole square, x3 minus x2 whole square plus y3 minus y2 whole square. Now we'll put all the values. The value of x2, this is 0, and x1, this is 5 whole square plus y2, the value of y2, this is 1, and y1, this is minus 3, then minus minus plus 3 whole square is equals to x3, this is x minus x2, this is 0 whole square plus y3, this is 6, and minus y1, this is 1 whole square. Now 0 minus 5 whole square, this is 25 plus 1 plus 3, 4 square 16 is equals to x square plus 6 minus 1, this is 5 square is 25. Now if you will transpose this 25 in left hand side, this will be negative. So this will be cancelled out by this term. So we are cancelling 25 by 25. X square is equals to 16. We'll find square root of this 16. We'll remove this square from left hand side. So we'll take square root of 16. Then this will be plus minus 4. Means the value of x will be plus minus 4. Find the ratio in which the line segment joining A 1 comma minus 5 and B minus 4 comma 5 is divided by x-axis. Students, you know very well, point on x-axis will be x comma 0. We have 2 points A 1 comma minus 5, B minus 4 comma 5, and this point P divides this line segment and coordinates of P x comma 0 because this point is situated on x-axis. Now we know section formula y is equals to m2 y1 plus m1 y2 upon m1 plus m2. Now we are putting the values of y and y1 y2 m1 m2. The value of y, this is 0, m2 we will write like this only. The value of y1, this is minus 5 plus m1. The value of y2, this will be 5 over m1 plus m2. Taking 1 in the denominator. Students, if two fractions are equal, we know very well, we will do cross multiply. To multiply this 0 and 1 plus m2. You get here 0 is equals to 1 into this term minus m5 m2 plus 5 m1. Transposing this term 5 m1 in left hand side, so you get here minus 5 m1 is equals to minus 5 m2. Minus minus cancel out. We will take this m2 in the denominator of m1 and 5 in the denominator of 5. m1 upon m2 is equals to 5 upon 5. 5 1 5, 5 1 5. Then the ratio m1 ratio m2 will be 1 ratio 1. If 1 comma 2, 4 comma y, x comma 6 and 3 comma 5 are the vertices of a parallelogram taken in order, find x and y. Students, we are making a parallelogram A, B, C, D and vertices are 1 comma 2, B 4 comma y, C x comma 6 and D 3 comma 5. We know very well O is the midpoint of AC and O is also the midpoint of B and D. So we are using a midpoint formula. We have written here O is the midpoint of A and C. So coordinates of O, we are finding coordinates of O. We will add x1 plus x2 upon 2 comma y1 plus y2 upon 2. Your x1 is 1, y1 is 2, x2 x and y2 6. So we are writing here 1 plus x upon 2 comma 2 plus 6 upon 2. Similarly, O is the midpoint of B and D. We are writing here O is the midpoint of B and D. So coordinates of O 3 comma 4, 3 plus 4 upon 2 comma 5 plus y upon 2. Now these are the coordinates of same point. We will compare first by first and second by second. 1 plus x upon 2 is equals to 7 by 2 and 8 by 2 is equals to 5 plus y upon 2. Now 2 cancel out, 2 cancel out. We will transpose this 1 in right hand side to x is equals to 7 minus 1. So x will be 6 and we are transposing this 5 in left hand side. So we are getting here 8 minus 5. So y will be 8 minus 5, this will be 3. The value of x will be 6 and the value of y will be 3. Find the coordinates of A where AB is the diameter of circle whose center is 2 comma minus 3 and B 1 comma 4. Students, we are making a circle whose center is 2 comma minus 3 and coordinates of point B, this is 1 comma 4. We have to find A. Let this point will be x1 comma y1. Students, we know O is the midpoint of A and B, so we are using here midpoint formula. X equals to x1 plus x2 upon 2 comma y equals to y1 plus y2 upon 2. We have to find the value of x1. The value of x is given here. X is 2 and x1 we have to find plus x2, this is 1 upon 2. Now two fractions are equal, we are doing cross multiply. So x1, if we will do multiply 1 by x1 plus 1, so we will get here x1 plus 1, 2 2 ja 4. We are transposing this 1 in right hand side. So x1 equals to 4 minus 1, this will be 3. The value of x1 will be 3. Similarly, y equals to y1 plus y2 upon 2. The value of y is minus 3. This will be y1 and y2, this will be 4 upon 2. Now two fractions are equal, we are doing cross multiply. So 1 into y1 plus 4, this will be y1 plus 4 and this will be minus 6. We are transposing this 4 in right hand side. Y1 will be minus 6 minus 4, so this will be minus 10. Coordinates of this point A, x1 comma y1, coordinates will be 3 comma minus 10. We can write here 3 comma minus 10. So this point will be 3 comma minus 10. Find the coordinates of the point which divides the join of minus 1 comma 7 and 4 comma minus 3 in the ratio 2:3. Students, we will use here section formula. We know very well. We are using points minus 1 comma 7, 4 comma minus 3 and a point P divides this line in 2:3. So this is M1, this is M2. We are writing here M1 ratio M2, this is 2:3. This is the value of x1, this is y1, this is x2, this is y2. We know section formula. X is equals to m2 x1 plus m1 x2 upon m1 plus m2 and y is equals to m2 y1 plus m1 y2 upon m1 plus m2. We will put all the values. The value of m2 is 3k. x1, this is minus 1 plus m1, this is 2k. x2, the value of x2 is 4. In denominator m1 plus m2, this will be 2k plus 3k. Now this will be minus 3k, this will be 8k over 3 plus 2, 5k. 8k minus 3k, this will be 5k upon 5k, 5k cancel out, we will get here 1. Similarly, y is equals to m2 y1 plus m1 y2 upon m1 plus m2. The value of m2 is 3k into the value of y1, this is 7, and the value of m1, this is 2k, and the value of y2, this will be minus 3 upon m1 plus m2, 2k plus 3k. 7 3 ja 21k minus 2 3 ja 6k negative over 3 plus 2 5k, 21k minus 6k, this will be 15k over 5k. k cancel out, 5 3 ja 15. So we are getting here x equals to 1 and y is equals to 3. So the coordinates of this point, P will be 1 comma 3. Determine if the points 1 comma 5 2 comma 3 and minus 2 comma minus 11 are collinear. Students, we have to find these 3 points are collinear or not. Means we have to check. We are taking here 1 comma 5, 2 comma 3, minus 2 comma minus 11. This point is x1 y1, this is x2 y2, this is x3 y3. The value of AB, this is square root of x2 minus x1 whole square plus y2 minus y1 whole square. The value of x2, this is 2. The value of x1, this is 1 square plus the value of y2, this is 3, and the value of y1, this is 5 whole square. 2 minus 1, 1 square plus 3 minus 5 minus 2 whole square. Square root of 1 square 1 and minus 2 square 4, 4 plus 1 root 5. Now we will find the distance between B and C. BC is equals to square root of x3 minus x2 whole square plus y3 minus y2 whole square. The value of x3, this is minus 2, and minus the value of x2, this is 2 whole square plus y3. The value of y3 minus 11 minus the value of y2, this is 3. Then minus 2 minus 2 minus 4 whole square plus minus 11 minus 3, this is minus 14 whole square. Minus 4 square, this is 16, and minus 14 square, this is 196. We will add both, we will get here under root 212. Now we will find the value of AC. Distance AC we will find. AC equals to x3 minus x1 whole square plus y3 minus y1 whole square. The value of x3, this is minus 2, and the value of x1, this is 1 whole square plus the value of y3, this is minus 11, then minus the value of y1, this is 5. Minus 2 minus 1 minus 3 whole square plus minus 11 minus 5 minus 16 whole square. Minus 3 whole square, this is 9, and minus 16 square, this is 256. Now we will add both the numbers, we will get here under root 265. Now we will see here AB plus BC. The value of AB, this is root 5. The value of BC, this is 212 square root. We cannot add both. The value of AC, this is under root 265. We can say here AB plus BC is not equals to AC. So A, B, C are not collinear. If the sum of these two distances is equals to AC, then you can say these points are collinear. In this case, these 3 points are not collinear. Find the point on the x-axis which is equidistant from 2 comma minus 5 and minus 2 comma 9. Students, we will draw a figure. If we are taking a point on x-axis, then the coordinates of this point will be x comma 0. And we have a point minus 2 comma 9 and 2 comma minus 5. These 2 points are equidistant from this point P. Now what will we do? We will write AP is equals to BP. We have written here AP equals to BP because these 2 points are equidistant from this point P. Now the value of AP with the help of distance formula, this will be square root of x2 minus x1 whole square plus y2 minus y1 whole square. And the value of BP, this will be x3 minus x2 whole square plus y3 minus y2 whole square. We have written here x3 minus x2 whole square plus y3 minus y2 whole square. Now we have square root on both the sides. We will square on both the sides. Squaring on both the sides, we will remove square root from both sides. We will write here x2 minus x1 whole square plus y2 minus y1 whole square is equals to x3 minus x2 whole square plus y3 minus y2 whole square. Students will put the value. What is the value of x2? In figure we can see here the value of x2. This is x. We are putting here and x1. This is minus 2. Then minus minus plus 2 whole square plus y2. This is 0 and y1 we can see here 9. 0 minus 9 whole square is equals to x3 minus x2 whole square. x3 2 minus x2. x2 is x whole square plus y3. The value of y3 is minus 5. We can write here minus 5 and minus y2. This is 0 whole square. Now students, we will apply here a formula a plus b whole square. A plus b whole square is a square plus b square plus 2ab. 0 minus 9 whole square, this will be plus 81, is equals to a minus b whole square. A square plus b square minus 2ab minus 5 whole square, this is plus 25. Now x square will be x square will be cancelled out because we will transpose this x square in left hand side, then this will be negative, so we are cancelling here. 2 square is cancelled out, you will get here 2 2 are 4, x plus 81 is equals to minus 4x plus 25. We will transpose like term in one side, we are transposing minus 4 in left hand side, so 4x plus 4x, and 81 in right hand side. 25 minus 81, 25 minus 81, so this is minus 56, 4x plus 4x, this is 8x. 8 we have in multiply, so we can write in the denominator of minus 56, x is equals to minus 56 upon 8, so this is minus 7, the value of x will be minus 7. Now the point on x-axis, this is x comma 0, means x is minus 7 comma 0, means point on the x-axis, this will be minus 7 comma 0. Now this point minus 7 comma 0, this will be in the left hand side of this origin. Find a relation between x and y such that the point x comma y is equidistant from the point 3 comma 6 and minus 3 comma 4. We are making a figure in which x y is equidistant from 3 comma 6 and minus 3 comma 4. Now students, what is given here? The value of AP is equals to the value of BP. Both the distances are equal. We have written here AP equals to BP. That this is x1 y1, this is x2 y2, and this is x3 y3. We will use here distance formula. In the place of this AP, we are using here square root of x2 minus x1 whole square plus y2 minus y1 whole square. And in the place of this distance BP, we can put here x3 minus x2 whole square plus y3 minus y2 whole square. Now we have square root on both the sides. Squaring on both the sides, we will get here x2 minus x1 whole square plus y2 minus y1 whole square, x3 minus x2 whole square plus y3 minus y2 whole square. Now we will put all the values x1, y1, x2, y2 and x3, y3. The value of x2. The value of x2 is x minus x1, this is 3 whole square, plus the value of y2, the value of y2 is y, and minus 6 whole square is equals to the value of x3 is minus 3, and minus x2 is x whole square, plus y3, the value of y3 is 4, minus y2, this is y. Now we will solve this part. We will write x minus 3 whole square plus y minus 6 whole square is equals to minus sign is common between both the terms. Now minus is common. We will write here 3 plus x whole square plus 4 minus y whole square. Now a minus b whole square, this is a square plus b square minus 2ab. Then again a minus b whole square, we will write here y square plus 6 square minus 2y into 6. A plus b whole square, when you will square this negative term, this will be positive. So a plus b whole square, this is a square plus b square and plus 2 into 3 into x, plus a minus b whole square means 4 minus y whole square. We are applying identity. 4 square, this is 16, plus y square and minus 2 4 is 8y. Now x square will be cancelled out. You will transpose this x square in left hand side, so this will be negative. This both the terms will be cancelled out. So we are cancelling here. And 3 square cancelled out. Y square is cancelled out. This is minus 6x and this is 6 square 36. Then minus 12y is equals to, this is 6x plus 16 minus 8y. Now we will transpose all the terms. We will transfer all the term in right hand side. So what will we get here? We will get here 0. This is 6x plus 16 minus 8y, and this will be 6x minus 36 and plus 12y. 6x, 6x, 12x, and minus 8y and plus 12y. So this will be 4y, and 36 minus and plus 16. This is minus 20. Dividing by 4 will get our answer. 3x plus y minus 5 equals to 0. 4 3 ja 12 and 4 1 ja 4, 4 5 ja 20 equals to 0. So students, this is the relation between x and y. Find the coordinates of the points which divide the line segment joining a minus 2 comma 2 and b 2 comma 8 in 4 equal parts. Students, we have 2 points a and b. A minus 2 comma 2 and b 2 comma 8. These are the coordinates of this point. Now we are dividing this whole line in 4 equal parts. So we have 3 points here, Q, P and R. Students, you can see here P is the midpoint of AB. We have written here P is the midpoint of A and B. So coordinates of P, we will add first and divide by 2, means x1 plus x2 upon 2, minus 2 plus 2 upon 2, y1 plus y2 upon 2, 2 plus 8 upon 2. So after solving we will get P, this will be 0, comma 8 and 2, 10 upon 2, 5. So coordinates of P will be 0, comma 5. Now Q is the midpoint of A and P. Q is the midpoint of A and P. So coordinates of Q, we will add first and we will divide by 2, minus 2 plus 0 upon 2, comma 2 plus 5 upon 2. And this will be minus 1 and this is 7 by 2. Similarly, R is the midpoint of P and P. R is the midpoint of P and P. So coordinates of R, 0 plus 2 upon 2 and 5 plus 8 upon 2. So R will be 1 comma 13 upon 2. So these are the points. Find the area of a rhombus if its vertices are 3 comma 0, 4 comma 5, minus 1 comma 4 and minus 2 comma minus 1 taken in order. Students, we are making a rhombus A, B, C, D. Coordinates of A 3 comma 0, B 4 comma 5, C minus 1 comma 4 and D minus 2 comma minus 1. Now we know very well area of a rhombus will be half product of diagonals. Half diagonals are AC and BD. So we are writing here half AC into BD. Now we will find distance AC and distance BD. So distance AC, this will be x3 minus x1 whole square plus y3 minus y1 whole square. We have written here AC equals to root x3 minus x1 whole square plus y3 minus y1 whole square. Now we are putting the values x3 minus 1, x1 minus 3, y3 4 and y1 0 whole square, minus 1 minus 3 minus 4 whole square, 4 square, this will be 16, this will be 16. 16 plus 16 square root of 32, and we can write it 16 into 2. Square root of 16 will be 4 and square root of 2. This is the value of AC. Similarly, we will find BD. BD is square root of BD. Square root of x4 minus x2 whole square plus y4 minus y2 whole square. We have written here. We will put all the values. X4, this is minus 2, and x2, this is 4. Y4, this is minus 1, and y2, this is 5. Minus 2 minus 4, this is minus 6 square. Minus 1 minus 5, this is minus 6 square. This is 36, this one 36. 36 plus 36, this is square root of 72. We can write it square root of 36 into 2, this will be 6 root 2. Now we will find area of rhombus. So area of rhombus, your first diagonal is 4 root 2 and second diagonal is 6 root 2. So we have written here 1 by 2, 4 root 2 into 6 root 2, root 2 into root 2, this is 2. 6 4 are 24. Now 2 cancel out. This will be 24 square units. So area of this rhombus will be 24 square units.